Well, hi, good morning. Thanks so much for joining me in my shop here. Getting a bit of a late start this morning. It's April 26th. So what it appears to me is happening with this radio is something strange is going on with the automatic volume control, or the AVC system, if I can call it a system, in the radio. On FM, it seems to be operating okay. The magic eye seems to respond okay. Maybe a little weak, but it's there. On the AM bands, some weird stuff is happening. So in some cases, the eye, which is normally has two sharp bars on it, and then the bars just get closer and farther apart, always remaining very sharp. These bars, they stop being sharp and they become fuzzy, very fuzzy bars. And they overlap, and they're closed most of the time. Meanwhile, the radio is screamingly loud. Of course, I can control that with the volume, but it is producing a lot of volume. In fact, I can't control it with the volume. When I have it turned right down, it's still producing sound. So the impression I get from this is the AVC voltage is not being applied to some of the tubes, probably these two tubes here that are being affected by the AVC grid bias voltage, and they're not being affected. So this means that the gain of these tubes remains high even with a strong signal, and the result is far too much volume coming out of the radio, and an overlap, or the eye staying closed or even overlapping. And I would think the fuzziness is probably part of the picture too in some way. So I think really the place to start is with the schematic. We'll look at how the AVC voltage is, where it's developed and how it's presented through the radio, and what's involved here with these switches. I'm going to bet there's some switching going on inside there. So let's start with the schematic, see what we can figure out here. Okay, well, all the action's happening with this tube here. This is a busy tube. So one part of this tube is a triode, this part of the top here. It's just an amplifier amplifying audio. And the audio is being fed over through this long route to the grid of the output tube. This isn't where our problem lies though. The problem lies in the AVC voltage that's being developed and how it's being handled in the radio. The voltage is developed here at these diodes. You see a diode here, one here, and one here. Now, it looks like these two cathodes are the same, probably the same cathode. And this one looks separate. Now, some of these are for the AM side and some are for the FM side. So we can figure out the FM side pretty quick, because here's the FM detector arrangement, if I can call it that. Just double checking a couple things here. Disappears off the diagram. Well, let's go for a second. Let's say, okay, because of this 4 microfarad capacitor, I think this is the FM side of things. It's getting its signal out of here. Yes, definitely FM. This is FM. This part is apparently working okay in terms of producing an AVC voltage, which is being cast through the radio apparently appropriately. The other two must be for the AM bands. Now, we've got, well, got one hooked up here, so I'm thinking now probably this one and this one are combined to produce the FM detector. And it's a ratio detector based on the way these diodes are. And then this would be the AM detector down here, hooked up to this coil, which is the last AM IF. So the AM audio is coming out here along with some voltage. It's not, the DC voltage is not going that way, it must be going this way. We're on to the other page. So we have a line, and a line. About halfway down the page. Okay, we'll go to the other page. Come over here. A line, and a line. So it's hard to tell, but there's actually a line coming out of here. So here's the magic eye right here, and here's the grid for the magic eye, and you see it is getting switched either from down here or from up here. So let's just follow that idea for a minute. The magic eye is either looking at this or it's looking at this. Let's go back to the other schematic. I should tape these together, but it's a little hard to do on my computer here. So it's either this or this. This one is the AM side, and this one, no surprise, is the FM side. So right at the switch, things change. The radio operates with a different AVC voltage source. Okay, right at the switch. And the switch will be built into one of the push buttons, or some of the push buttons. Push button A. Not to worry about that. Now let's see where else. This AVC's got to be going elsewhere. It must be on this wire. We follow this wire. We go up here. Yeah, let's not follow it this way. Side. Could be that there's a wire coming out here, but it's cut off on this photocopy. Just neatly cut off right on the line there. So the grid is sticking out, cathode is sticking out, this thing is sticking out, and this is the wire we're following, which is coming off the bottom, which is coming through the detector. So this is the AVC line carrying on, a portion of which is fed down to the magic eye. So the magic eye is getting the same as everything on this line. That's what I really wanted to get to. Okay, we'll go back over. 1, 2, 3. Let's see if we can spot those. 1, 2, and 3, I think. Maybe down here. I may be wrong about that. So just following the AVC now. We know this line is the same as this connection. Through a large 1.5 megohm resistor right onto the grid of this tube. Let's see if we can follow it any further. That looks like that's the end of the road. Okay, after a little bit of a distraction, so I was following the AVC line coming, developed out of the AM side of things here, and it's applied to this grid on the mixer tube, and not quite sure what they're up to. I think I am now. So this is the oscillator side of things. These are the oscillator coils down here, I would imagine. Okay, and when the AVC voltage gets to this point, it can't go anywhere. It's got a capacitor blocking it from going anywhere further this way. Is this the only controlled tube in the radio? Okay, so if we look at the grids back here, this is the FM tube here. So this grid is blocked here by a capacitor. A resistor just goes to ground, so there's no AVC being applied here. This one, let's see, if you go this way, I'm just looking for DC paths. There are none that way. If we go this way, it just goes to ground, and it's blocked. So no DC can be applied to these grids externally, so to speak, or from an AVC voltage. So what is the FM AVC voltage doing here? Let's follow that one again. So we would pick it out of here. Coming across. It's on this middle line of the 3. Okay, middle line of the 3. Probably connecting here. So it's being fed to the grid of the eye. Is that all? That's all it's doing? Could be. It's not going back to control this at all. That's why we get a very different look. When we put it on the FM, the magic eye picture, or bars, clean up and look normal. And put it on AM, and it would appear that there's RF getting through. Let's look at it from that point of view. So it would look like there's RF getting onto the magic eye grid. So that could easily be coming from this on this line that only goes here. What would stick RF onto this line? Well, the most likely source is back here, where it's originally developed, right here. This is working through the diode. So there's ways in which the RF is eliminated from the AVC line. Well, that certainly goes all around and everywhere. That's the audio. This is the audio input here for the AM side of things. And the FM side of things, I'm not sure offhand. Yeah, not quite sure what's up. Not sure what's up with this connection from here back to here. Of course, this is the suppressor grid. So it could be some tricky use of the suppressor grid for some purpose I don't understand. Okay. And here the DC that's developed in the FM detector can make it to here. Just running over the same territory. Make it to this point here. When you push FM, this slides up, connects it, disconnects it here. Let's go back again. Now, is it in any way getting to that first tube? No. No, it's just feeding the eye. So all that's happening is you're taking a little bit of voltage off the detector here and using it to operate the eye. It's not actually controlling the input earlier in the radio, the radio's sensitivity. Very different systems. Different source of voltage, and everything's different. Okay, so going back to the AM side, the first place they're trying to get rid of any RF would be, I think, right here, this filter. That would be the first stage of it. What exactly is going on back this way? Not so sure. I'll look for a fairly large capacitor. We'll go on this side here, and we'll look for a fairly large capacitor. Here's one here. Looks like 0.047 microfarads. It's not terribly large. 0.05. 0.05, yeah, that's typical right here. Yeah, 0.05. So this is the guy who could be in trouble. Now, didn't I change all these 0.05s? Maybe not. I think we need to locate where this is. 116, I believe, is what that says. 116. Physically, where is that in the radio? connected, well, you can see here's grid number 2, so we would probably find this resistor fairly easily. But that wouldn't necessarily be connected to this capacitor. A capacitor could be anywhere on this wire. It can be all over the place in there. Jeepers, it's a hard one to spot. 116. How am I going to find that? Well, we'll just have to start tracing from somewhere, and the best place probably is off of here, pin 2 of this tube. ECH81, pin 2, trace to find at 0.05. Well, it's taken me a long time to trace out the circuit in here and finally arrive at the 0.05 capacitor, which is right there, which is the one I put in on this side of the board. Now, this is soldered in correctly. There's no shorts or anything. But just behind it, you can just see a little bit of it here, is this weird zigzaggy thing on the board of this Nordmende radio. And the same thing appears on other Nordmende radios I've recently been working on. The same zigzaggy thing is. Now I've got this capacitor laid up right against it. Electrically, directly, that doesn't really matter. This is an insulated capacitor. What would it matter? But it is possible that I put this capacitor in so the outside foil is connected to the high impedance side of the circuit that the capacitor is in. One side is this ground area, and the other side is going right into the IF cans. So we can guess this is a high impedance connection. So if the foil, the outside foil, is over here, it's connected to this lead, then it's pretty easy to imagine that there's some interaction going on between the capacitor foil and this weird zigzag thing that's in behind here. The solution could be just turn this capacitor right around. Just turn it around, put it back in, and that would, if my theory's correct, that would move the outside foil connection over to here on the ground, and so the outside foil would be grounded, and that would shield the capacitor from whatever's going on in this zigzaggy piece here. So that's what I'm going to do. I'm just going to flip it around the other way, see if that makes any difference. Don't really know what's going to happen. Bit of a long shot, but I haven't got much else here. So I've moved it a little bit from the zigzaggy thing. I think, another alternative would be to swing this end of the capacitor down in here somewhere and get it away from this. But I've turned it around. We'll see if this makes any difference. I really don't. I can't imagine that's all that's been going on. But let's see. Because what I imagine doesn't really matter. Let's see what happens. I'll be very impressed if this actually fixes the situation. So, no FM antenna installed. Let's plug it in. Okay, here we go. Okay, good. The magic eye. Oh, you want to be able to see that. So the magic eye appears to be straightened up. nice sharp edges on it now. Nothing much to pick up in here. Station should be right around 590 here, right around in here. Well, it seems to have fixed the problem. Find it a little hard to believe, but I saw what I saw. Let's pop on the short wave. I don't have the antenna connected, so let's not bother. We'll test the FM here. Again.
It's Aaron Cole with One More Day on Life. Got up in front of like replacing the
And so I would watch, Fred Penman and Friendly Giant on Sesame Street. And I would have all the puppets and outside anything. And I used to think that Sesame Street was downtown Calgary when I was like 3 years old. And I used to point downtown and tell my mom, can we go down there? Big Bird's down there, Cookie Monster's down there. The Muppet Show's over there. And she had a hard time trying to tell me how far Sesame Street really was. It was in New York. And for Christmas when I was like 4, I got all the puppets that were out at that time in the stores.
Yeah.
So I just, all like...
Okay, another problem solved, I think. It just seems to have fixed the problem. So I guess maybe my theory was correct. It has to do with the outside foil on the capacitor. These modern yellow capacitors I buy, they don't have the outside foil mark. And I've just taken to kind of ignoring the whole issue. And there's certainly one case there where ignoring it's not a good idea. Okay, so that's it for today. Tomorrow I think I'm ready to start doing some alignment work with this radio, and we'll see what we get out of it. Thanks a lot for watching.